In this question here, we are being told that the sun has a surface temperature of 5780 Kelvin. The luminosity of the sun is 3.85 times 10 raised to the power 26 watts. Calculate the radius of the sun. So, in this question here, we are going to use Stefan-Boltzmann law. We are going to use Stefan-Boltzmann law. Now, Stefan-Boltzmann law states that luminosity is equal to 4 times pi times radius squared times the Stefan-Boltzmann is constant. This is not 6, but it's supposed to be this way. Constant times the temperature power 4. Then from here, we need to arrange this one because we need to calculate what? We need to calculate the radius of the sun. So let us arrange it, whereby now to calculate the radius of the sun, it will be radius is equal to the square root of the square root of luminosity over 4 pi Stefan is constant times the temperature power 4. Now at this point here, I need to show you something. This one here is the radius, the one we are looking at. L here is the what we call the luminosity. The ones we are calculating, luminosity. Then this one here is the Stefan-Boltzmann constant. Okay, then this one here is the temperature. Then again here we need to calculate this one here, because already we know radius is equals to that one. Now it will be radius equals to square root of luminosity over 4 pi density times temperature power 4. So which is going to be square root of 3.85 times 10 power 26, because that is the luminosity, over 4 pi times the Stefan-Boltzmann constant, that is 5.67 times 10 power 8 times. Remember, at this point here we are being told that the temperature is 5780 power 4. Okay, so the next step, after calculating that one, we get that the radius of the sun is 6.96 times 10 raised to the power 8 meters.